Good morning everyone. Here we are going to discuss a few concepts, basic concepts of class 10th syllabus, in which first we will be doing a little discussion about Pythagoras, but that is not our topic, Pythagoras theorem. I have taken two right angle triangles. Here one is and they are both isosceles as well. Isosceles right angle triangle, in which the two legs of the right angle triangle are equal, 30 centimeter and 30 centimeter. So, and this is AC is hypotenuse. Here if I call this triangle, name the triangle as ABC. AB is 30, BC is also 30, and I have calculated using Pythagoras theorem, calculated AC, the hypotenuse, and it found to be 30 root 2 centimeter. Now coming to the other triangle, a little bigger one, and it is also the same isosceles right angle triangle, in which my legs of the triangles are, one is 40 centimeter, the other also 40 centimeter, hence it is isosceles and it is right angle, and calculated the hypotenuse now found to be 40 root 2 centimeters. This is 30 root 2 centimeter. If legs are 30, hypotenuse is 30 root 2, and if legs are 40, hypotenuse is 40 root 2. Now, because the one of the angle is 90 degrees and the triangle is isosceles, the remaining two angles should be equal. That the property that we have learned earlier. It is one is 45, the other also is 45. Here also the case is same. Now, for my conclusion, we are going to write a conclusion first regarding the triangle ABC. I am taking the ratios AB by AC. Okay. With respect to this triangle 45 degree, this is my opposite side and this is the hypotenuse. Let me write it. Write it as, let me make it more clear, opposite, and this is I call hypotenuse. In any right triangle, the side opposite to the angle 90 degree, we call it hypotenuse. Everybody knows it. And with respect to this 45 degree, it is again same thing, opposite upon hypotenuse. Okay. Now this is opposite with respect to angle 45, this angle 45. Now this what it will become? It will become the adjacent side. Similarly here also. Now we are going to discuss the ratio of the particular sides. First AB by AC means in terms of opposite and hypotenuse, 30 by, how much I got this one? This one I got it as 30 root 2 centimeters. And how much this I got? I got 40 root 2 centimeters. Now we are taking the ratios of the triangles, ratios of the sides of the triangle AB by AC. AB we know it is, we have drawn 30 centimeter and we got the side hypotenuse as 30 root 2 centimeters. So if I take AB by AC, I got 30 upon 30 root 2. On simplification, I got it as 1 by root 2. Right. Next is the adjacent side upon hypotenuse, which is 30 upon 30 root 2, BC by AC, 30 upon 30 root 2, which is 1 by root 2. Now comes last ratio remaining is AB by BC, AP upon BC, which is 30 by 30, both the sides are 30. So, it will be 30 upon 30, if I cancel simplify I got 1. Now the trick, now the question, if I take another triangle, another right angle triangle which is isosceles but having different measurements, here the two sides are 30 and 30, now I am taking it as 40 and 40. What happens if I take the ratios? The same ratios here also. Now it is opposite by hypotenuse, PQ by PR. PQ by PR is 40 by 40 root 2, which is 1 by root 2. Again here also 1 by root 2, here also 1 by root 2. Now, adjacent upon hypotenuse 40 by 40 root 2, here my final result is 1 by root 2. I am getting 40 upon 40 root 2 as again 1 by root 2, ratios are same, whether it is AB by AC or PQ by PR, opposite side by hypotenuse give me the same result. Adjacent side by hypotenuse 1 by root 2, here also 1 by root 2, and if I take last ratio, the possible ratio is AB by BC with respect to, if I said opposite with respect to angle theta 45 degree, opposite by adjacent, here also opposite by adjacent, that is AB by BC as 30 by 31 and PQ by QR is also 1. What conclusion we can derive from it? The conclusion is, irrespective of the length of the sides of a triangle, if the angle is fixed constant, the ratios of the sides of the triangle, the three basic ratios remains the same. That means AB by AC, what it is actually in terms of angle theta, these are opposite upon hypotenuse. We give it a name, particular name. This ratio we call opposite side upon hypotenuse, we call it as, name it as sine of the angle theta, sine theta. And it is same whether the triangle is big or small or whatever it is. Even in your bag, in your compass box, you will be having these two instruments which we call it as set squares. And these set squares, one is isosceles right angle triangle. You can measure on your own and find their respective ratios, these three basic ratios. You will find that in all cases it will remain fixed. Or I am having in my geometry instrument box another isosceles right angle triangle, and if I found it is already marked, and one side is given to me as 30 centimeter, this also is 30 meter because isosceles, so they must be same, and this is given to me as 40.4, and which is nothing but 30 into root 2, which will be nearly equal to 40.4, 40.42, something like that. So this is also what do you call, it is satisfying our properties, ratios, whether it is opposite side by hypotenuse or adjacent side by hypotenuse or opposite by adjacent, all are fixed. Whether my triangle is as big as my geometrical instrument box of the school or as small as the instrument that is there, set square that is there in your compass box, both will give you the same ratio. And this is the basic of trigonometry. The topic that we are discussing over here is trigonometry. So now you got the name of the, because if given a particular angle, given angle 45 degree, the basic three ratios, opposite by hypotenuse, adjacent by hypotenuse or opposite by adjacent, remains the same, irrespective of whether the triangle is big or small. So we have, this is the basic, this is the fundamental of the whole chapter, trigonometry. Now if I change the angle from 45 to 30, 45 to 60, 45 to 0, 45 to 90, there will be always fixed values. They will give me I end up with fixed values. In my set, in your box also, set square, there will be another set square in your geometry box, and here the angles are, one is 90 degree, obviously it is also a right triangle, 90 degree, this will be 60 degree, this will be 30 degree. And in this case also the ratios, if I take with respect to angle 30 degree, opposite side by hypotenuse, now you will see it is already marked, and this is marked as 25, and my hypotenuse it's marked as 50. So, this sine 30 degree opposite by hypotenuse, that means 25 by 50, which is half. Sine 30 is half. Whether it is half for this big triangle, it is also half for the smaller one, which is there in your compass box. You measure, you can find it out on your own. You do this exercise on your own. It will be the same. So, this is the basic, the fundamental of the trigonometry. Let me write down the names that I have written over here, only the ratios. Now, I will give them a name. This opposite by hypotenuse, I call it as sine of the angle theta with respect to theta, which is here 45 degrees. So, whether this is 30 by 30 root 2 or it is 40 by root 2, sine 45 will remain same 1 by root 2 in both the cases. Now, if it is adjacent by hypotenuse, there is another name for it, we call it cos theta. Here also cos theta remains the same, no change at all, irrespective of the length of the sides of the triangles. Only what is fixed? Fixed is the angle 45 degrees. Then comes tan of the angle theta. It is same tan, I am sorry, this is cos and this is tan. In both the cases, not in both the cases, in every case, whatever be the length of the sides of an isosceles right angle triangle, the ratios 1 by root 2 for sine, 1 by root 2 for cos, 1 for tan, it will be fixed. Now, we have these three basic fundamental ratios. Now, we do not have these three ratios, we have their reciprocals as well. Reciprocals means, if my sine is AB upon AC, what is AB? AB is opposite side. We are considering it as opposite to the angle theta, to the angle 45 degree, and AC is fixed hypotenuse. If I reverse it and write it as AC upon AB, then there is another name for it. Reciprocal of sine is cosec, cosec of the angle theta. Ratio is same, just it is the other way round. It is rotated, it is hypotenuse, in place of hypotenuse opposite side will come, in place of opposite side hypotenuse will come. So, they are same, one and the same, reciprocal to each other. It has been given another name, because we are going to use it and we are going to derive lot of formulas. I cannot simply keep on telling sine and reciprocal of sine. So, for that to avoid that confusion, we have given a particular name for that reciprocal, and that name is, for sine it is cosec. Let me write it, the reciprocal of sine cosec the reciprocal of cos is sec, sec of the angle theta, secant of the angle theta, cosecant of the angle theta, or for tan for that matter is cot, cotangent of the angle theta. So, we have three ratios, basic ratios, and their three reciprocals, altogether 6. Based on these 6 trigonometric ratios, the whole chapter of trigonometry depends. And in the next class, we will be discussing about this relationship between their ratios and their reciprocals. Thank you.